Good morning everyone. So today my group will be presenting chapter 2 Antiquity from Proto-Mathematics to Theoretical Mathematics. So here's my group member. First me myself, Yogita Maiswaran, Go Siang Ki, Qasim E and Nur Safira binti Muhammad Tahir. As an introduction for this topic, we will be talking about mathematics in the ancient Near East. First, Egyptian mathematics, followed by Babylonian mathematics, Greek mathematics, and pre-Euclidean geometry and the elements. To begin with, Egyptian mathematics. Egyptian mathematics is the mathematics that was developed and used in ancient Egypt. The best known sources of ancient Egyptian mathematics in written format, there are two. First is the Rhine Papyrus, second will be the Moscow. There are some elements that have to be mentioned when it comes to Egyptian mathematics. The first is numerals. The picture below shows hieroglyph. Hieroglyph was a character of the ancient Egyptian writing system. Next will be algebra. The picture below shows AHA in hieroglyph. AHA problems involve finding unknown quantities if the sum of the quality and parts of it are given. Furthermore, the ancient Egyptians were the first civilization to develop and solve second-degree equation, which is quadratic equation. This information is found in the Berlin Papyrus fragment. The Egyptians also solved first-degree algebraic equations found in Rhine Mathematical Papyrus. Next will be about geometry. The ancient Egyptians knew how to compute areas of several geometrical shapes and the volumes of cylinders and pyramids. There are only a limited number of problems from ancient Egypt that concern geometry. Next is about the multiplication and also division. As you can see, the first picture shows an example of ancient Egyptian method of multiplication. To multiply 3 by 6, first they take the combination of blocks on the first side which add up to 6 in the bracket of 2 plus 4 and count up the corresponding blocks on the third side 6 plus 12 to give a total of 18. The next picture shows an example of how division is being carried out. To divide 3 loaves between 5 people, first they divide 2 of the loaves into thirds and the third loaf into fifth. Then they divide the leftover third from the second loaf into fifths. So each person gets 3 over 5 loaves.
Babylon's mathematics is the mathematics that was developed and used in Babylon's 2000 to c. 1600 BCE. So Babylon's mathematics divide to 3. There is numerals, algebra, and geometry. We can see this is the symbol is 1, 10, 60, and 600. This is coniferous numerals. Conifers were right on the soft clay and then baked under the hot suns. So the Babylon system of the mathematics was sexagesimal base 60 numeral system. Example like C, we can see nowadays used until today is 60 seconds in a minute, 60 minutes in an hour, and 360 degrees in a circles. For algebras, the Babylon's clay tablets YBC 7289 it give an approximate of square root 2 in 4 sexagesimal figure. For quadratic equations, first they will use x squared plus bx equal to c. After that, they change to x equal to negative b over 2 plus square root b over 2 square plus c. For cubic equation, they use ax cubed plus bx squared equal to c. And then this we can see is Platinum T22 tablets which contain a list of the Pythagorean triple. Example like integral ABC, this is they will use a squared plus b squared equal to c squared. So for the geometries, this is they will use Pythagoras theorems for right triangle. At that time, pi is equal to 3. For they will also use accurate formula for solving the area, volume, and other measurement of the easy geometric shape as well as trapezoids.
Hi, I am Go Sanki. I am going to present grade mathematics. Grade mathematics can divide into 2 grades. First of all is Thales. So what we know about Thales? Thales can be called as of the father of geometry. He is the first mathematician. So he introduced the logical proof based on deduction reasoning. So there is two examples we can see. First of all, we can see the base angle of the isosceles triangle are equal. So whenever we see two straight line intersection, the opposite angle are equal. So that is why first of the example, he computed the height of pyramid using the shadow. Then second, what we can see application that Taylor's use is to figure out a ship was out at the sea by X or Y. Second, grades is Pythagoras theorem. He investigated his theorem from the e-matter and intellectual point of view and discovered this theory is a irrational quantity and construction of Mandel figure. He defined a point unity having position. So what we can see from the formula a square plus b square equals to c square. A and b is the leg, c is hypotenuse. So as we see that from the example above, tell us the ship and the sea. So the right angle is 90. So the longest one is hypotenuse.
Okay, now I will continue on pre-Euclidean geometry and the element. Okay, now we see the definition of Euclidean geometry, which means the study of plane and solid figure on the basis of axiom and theorem. Okay, axiom is the statement that always true does not have to be proved, while theorem is statement we know it is true and has proof. Okay, let me see the figure here. It is the Euclidean plane that include of the triangle, that is the sum of angle is 180. Which is it is also a straight line. Okay, it also has parallel line which is remain parallel, and the circle is c equals to 2 pi r. Okay, let's continue to the element. The element is the mathematical formal written subject which consisting of 13 books attributed to the ancient Greek mathematical Euclid, which my friend explained just now. Okay, so the book cover about the plane and solid. The second one is the elementary number theory, which is the positive integer, negative integer, and whole number. And the last one, it cover the topic of incommensurable line, which is two line segment which the ratio of length is irrational. Okay, so now we will move to conclusion. So we have learned about the mathematics in the ancient eras, which is the in Egypt mathematics, Babylon mathematics, Greek mathematics, and pre-Euclidean geometry and its element. So from this we get to know that Babylon mathematics was much more sophisticated. Okay, so that's all from us. Thank you.